All right. Welcome back to linear algebra. Let's jump into Anki. What the? Here we go. A. All right. What is an upper triangular matrix? It's a matrix in which all the entries below the main diagonal are 0. A lower triangular matrix is a matrix in which all the entries above the main diagonal are 0. Triangular matrix is a upper triangular matrix and or a lower triangular matrix. If E is an n by n matrix, how might you obtain the inverse of E from I? So we're talking about an elementary matrix. Basically, from I, you're gonna basically do the opposite matrix, opposite elementary row operation you used to get E from I. You'll use the opposite to get the inverse of E from I. How are the rows of matrix A affected if it is multiplied on the left by a diagonal matrix? Well, each successive diagonal entry is going to multiply through by each successive row. So the first diagonal entry will multiply through the first row, the second diagonal entry will multiply through the second row, etc. If the matrix B results from matrix A by performing one elementary row operation, how might you recover A from B by performing one elementary row operation? You're going to do the opposite again, like literally we already just talked about this. How are the columns of matrix A affected if it is multiplied on the right by a diagonal matrix? Same with this time the columns. It's each successive column is going to be multiplied by each successive diagonal entry. What can you say about the number of solutions of a consistent linear system or system of linear equations? It's got exactly one or infinitely many. There's no other option. What must be true for a triangular matrix to be invertible? All of the entries for the main diagonal must be non-zero. All right, I'm going to jump back in, or I'm going to grade what I did from yesterday, then I'll come back to recall how that went. Well, I'm getting much better at the domain codomains because I got them all right from yesterday, and I got that finding the inverse from 1.5, that review question right as well. So I'm going to continue working through more practice problems, and I'll be back to recall what I learned in a little bit. I didn't remember. There we go. All right. Talk to you in a bit. Hopefully that didn't mess up the mic. Yeah, I went ahead and used, I switched back, flipped through the book to try to figure out what was going on here, because these equations kind of confused me, and I figured it out. So I actually, okay, this is how you do it. See how there's these W's, but they're not really W's, they're like some Greek symbol. I can't remember what they would be called, though. But x1, x2, x3, so we're turning this 3 unknowns, there's three variables, I should say, into 2 variables. So what we're doing is we're going from R3 to R2. I might have written, this is where I didn't understand it yet. Then once I understood that, and also it's pretty simple. You just turn these into matrices. This would turn it into a matrix equation, right? Because a linear transformation or a matrix transformation can be represented as basically a matrix multiplication. So here's A. Then the next one, we're doing the same thing, trying to find the standard matrix, but we're given these formulas rather than equations. So we're going from 2, transformation of x1 to x2. And then I think this is 4 because it says x2 comma, negative x1 comma, this little expression comma, and then there's 4, right? and I wrote it like this. A times this is this. This can also be written as T, transformation of, and so that's how you would rewrite it. And you know A is going to be a 4x2 matrix, which ultimately ends up being. But in a standard matrix can be found basically by partitioning the transformations of each of the standard basis vectors. And so standard basis vector 1, the transformation of standard basis vector number 1. So plugging in x1 and x2 into these x1 and x2s get you that. And same thing for the second standard basis vector. Then partition, that's what it looks like. So I think I actually got that one right. This 13, I didn't look at the book. I'd really try never to look back at the book, but I did look back in the book because I was trying this number 11a yesterday and really not knowing what to do, but now I understand a little bit better. Matrix transformations, linear transformations, domain, codomain, you know, standard basis vectors, and standard matrices. I understand that all a little bit better now after today. So that's it for today. Talk to you tomorrow. See you.